All right, we are going to talk about acceleration. So a couple terms that you've started to hear me use is velocity. So velocity and speed are very similar. Velocity includes speed of an object, but it also includes the direction of motion. So if it's going a certain way or if it's going another way, velocity takes that into account. Sometimes that means that velocities are negative, sometimes that means they're positive, so on and so forth. So the difference between speed and velocity is that velocity includes direction, whereas speed does not. Speed just tells you how fast something is going. Acceleration is the rate of change of velocity, so basically how much velocity is changing. Acceleration occurs when an object changes speed, its direction, or both. So it changes its speed or direction or both. Okay, so one of the other. When you calculate acceleration, you have to understand that acceleration is going to be the change in velocity in meters per second over the time it took to change that velocity. How we calculate a change in velocity is we look at the final velocity, how fast was it going at the end, how fast was it going at the beginning. So you calculate that by saying, okay, the final velocity, how fast it was going at the end, minus the initial velocity, how fast it was going at the beginning. And that gives us this. So change in velocity, this delta, this is a Greek letter delta, and that means change. So change in velocity equals the final velocity minus the initial velocity. That's what these letters mean. The F for final, the I for initial. So the actual acceleration formula is A equals Vf minus Vi, that's the final velocity minus the initial velocity, over the time it took for that to happen. There are two types of acceleration. We've got positive acceleration and negative acceleration. Positive acceleration is when you are speeding up, and it should be a positive number when you calculate it. That's just something to remember, a little cheat sheet. Negative acceleration is when you are slowing down and should be negative when you calculate it. So obviously positive should be positive and negative should be negative. So here's an example, okay, that we can calculate out, just a very easy example. A plane takes off from a stopped position. Within 20 seconds, it reaches 80 meters per second. What is its acceleration? So here we can identify the pieces. So do we have a final velocity? It reaches 80 meters per second, so that's our final velocity. Our initial velocity, well, we know it was stopped, so when something is stopped, its velocity is 0. So we have our final, we have our initial. Do we have our time? 20 seconds, within 20 seconds. So we have 20 seconds, so we'll take our final, which is what it is at the end, the 80 meters per second, minus our initial. Remember, it started at a stopped position, so that's 0. So 80 meters per second minus 0 meters per second. That will give us 80 meters per second. And then we divide it by our 20 seconds, and we are going to get 4 meters per second squared. And meters per second squared is the unit for acceleration. Anytime you're talking about acceleration, that should be the unit you're using. So make sure you remember that, meters per second squared, or some unit of length divided by some unit of time squared. That is all acceleration. You can also look at this and say, oh, well, 4 is a positive number. Well, this is positive acceleration because the plane is speeding up from being stopped to going a certain speed. So the plane is speeding up, so the acceleration is positive, so our acceleration number should be a positive number. I checked, yep, 4 is a positive number. We're good to go. Negative acceleration. So this usually happens, remember, when something is stopping. So a bike is traveling 3 meters per second and comes to a stop in 2 seconds. What is its acceleration? You might say, well, it doesn't have an acceleration because it's coming to a stop. But remember, there are two types of acceleration. There's the positive acceleration when something is speeding up, and the negative acceleration when something is slowing down. So we have a final velocity, and the final velocity is it came to a stop. So the final velocity is going to be 0 meters per second. We have our starting velocity because we know what it was traveling at, and that is 3 meters per second. We have our time, which tells us how long it took for this change, the 3 meters per second to the stop, to happen, and that is 2 seconds. So what is its acceleration? Well, our v final is 0 because that's what we stopped at. Our v initial is what it was traveling at, so that's 3 meters per second. And our time is t, and that is how long it took for that change to happen, which is 2 seconds. So 0 minus 3, that is going to be negative 3, divided by 2 is going to give you a negative 1.5 meters per second squared. Notice how this is a negative number. Well, the bike is slowing down, so the acceleration should be negative. It's negative, we're good to go. All right, so that is acceleration. I hope you understand. Please write down any questions you have.